Okay, great. So Dora Kai from NCSA is our first speaker today. She's going to be talking to us about data analysis on massive online game logs. So some of this work is coming through ECSS's novel and innovative projects area led by Sergio. And what we're starting to see with things like online games and social media is a lot more opportunities for social scientists to analyze data on supercomputers. So really kind of novel uses compared to partial differential equations that many of us are familiar with for years and years. So there are a lot of challenges for these new user communities, and I'm interested to hear from Dora today how this project with Marshall Scott Poole at UIUC went. So without any further ado, why don't you take it away here, Dora?
Okay. Today I'd like to talk about a project I have been doing for many years. This project is focused on data analysis on massive online game logs. Online games has been very popular in recent years. Based on the recent report, 135 million gamers are playing worldwide, and thousands of game titles have been developed, and those game titles have been available on the internet. Many game companies have started to collect game logs for their research and for their business study. Game log is try to catch every actions the player is doing and try to catch their behavior. So game log provide a unique opportunities for social science study. Many researchers have been working on game log analysis, and there are even some conference dedicated for game log analysis. This project has run 6 years. It started in 2007 by 4 PIs and 15 graduate students from 4 universities. And you can see this team is really made up by the researchers from multiple domains. So this team has social scientists, there's a computer scientist, and there's some communication scientists. The data flow is pretty simple for this project. The project acquires game logs from game companies, and then those game logs are integrated together and put into a very big database. Then the users can use the local computer or use the HPC supercomputers to access the database to retrieve data and do the data analysis. There are many research issues in game log analysis, and I just list some research issues here, and I don't have the time to go through all those questions. If somebody interested, we can talk about offline. And all those issues this team has been working on, and a lot of research result has been generated and published in papers. This project has been doing very well, and the project has been funded by NSF, Army Research Lab, Air Force Research Lab. This project has published more than 40 conference and journal papers, and has trained more than 30 graduate students, and has graduated 8 PhDs. We have built a comprehensive game log database. The project, especially this very large comprehensive game log database, has attracted a lot of collaborators from many universities and game companies. 2 of the PIs of this project has created a spin-off company in 2010. I have been involved in this project for 5 years. I joined the project since 2008. I designed and constructed the big database from the scratch. The current database size is 4.5 terabytes. I have integrated game logs in 3 languages, English, Chinese, and Japanese, from 4 online game log titles into one single database. I have trained and helped researchers to effectively use HPC and the database in their research. I also joined the research team and working on several research issues. For example, I work with somebody to build the prediction models based on players' behavior. I also work with other people to design and implement the algorithm for group detection. And all those work has been published in papers. Today, I don't have the time to talk about it in detail, but today I really want to spend a little bit more time to talk about my recent effort on developing a tool to visualize the social network we discovered. The new tool, we name it Social Map Explorer. It is a web-based application, and it is implemented using Google Map API, using HTML and JavaScript. It is a highly interactive tool. The user can select many variables and parameters and based on their interest. This tool uses visual features like color, size, shape, weight, and font to represent network features.
Dora, I'm going to mute the participant noise for a moment, okay? Hang on.
Okay.
Presentation mode is now enabled.
Dora, do you want to say something?
No.
Oh, great. I can still. I just wanted to check if I could still hear you. Yep. Go ahead. Sorry.
Okay. This tool visualizes data on real map, so you can tightly combine the time and the spatial information with other study attributes. This tool is really capable to process a very, very large data set and with the good performance. This tool has 3 modules, and I'll talk about each module and in the later slides. The workflow for this tool has 3 steps. The first step is to do the data summarization. The game log is collected by game company at the resolution of seconds. So this step, we summarize the data to aggregate the data to higher level. For the time dimensions, we aggregate the data to 1 minute, 15 minutes, 30 minutes, and 1 hour. For the location dimension, we aggregate the data to zip code level and county level. This summarization is very important. It reduces the size of the data set and also provides the flexibility for users to choose the different granularity when they're doing the data analysis. The second step is to do the geocoding. We match players' zip code with U.S. zip code book and assign a latitude and longitude coordinates for each player. This step is also very important. That ensures we can pinpoint the players on real map at the right location, and also ensures we can visualize the features with high precision. The third step is to do the data visualization. That is, visualize the features to represent the social network features. The first module, we call it Net Viewer. It is designed to analyze network dynamics. This module traces the network event and makes the link between the involved parties. This tool is highly interactive, and the user can choose different data sets and can choose a different time interval and can run in either in the dynamic mode or static mode. Here is this picture shows some output from the net viewer. This shows a chat network over 48 U.S. continental states at 4 different hours. The line is drawn here and has different colors. And the light blue color means lower volumes, and the dark red color means the higher volume. So we use gradient colors to represent the volume. And you can see, and after midnight, and the network volume dropped significantly. And this is aligned with the low activity of a game player. And during the day, the density of the network becomes denser and denser. And after players come back online. And we also can see the density at East Coast is higher than the density of West Coast. This is because the population of East Coast is higher than the West Coast. We also can see a shift of the density area from East Coast towards to the West Coast around midnight. This is because the time zone difference. If
so, the time is the East Coast time?
Use the Pacific time. The second module is the group detector. This module is designed to detect a group and visualize a group evolution. This module scans game logs and identifies a trigger event for group reorganization. For example, a new member added to a task and a member leaves the team or the task is complete. All those trigger events, this module can detect it. And this module also allows users to choose game task and time period, and can display either single group or multiple group, can run either in dynamic mode or static mode. This figure shows the course, the revolution of the course of a group. You can see the group starts with single players. Then more and more players added to the group and playing the same task. And the size of the group fluctuated from 1 to 7. And after a couple hours work together, and the task finally finished, and the group disbands. You can see some information window pop up. It's showing the group event. Those events trigger the group reorganization. The third module is the correlation finder. This module is designed to discover the correlation between census data and the gameplay behavior data. This module uses a unique two-layer representation to discover the correlation. And one layer is for census data, and the other layer is for the gameplay behavior data. And I will give more details in the next slide to see how it works. This module also allows users to choose parameters or variables from a census data set and from a game behavior data set, and to choose location and region. And the visualization done in this module is all in a quantitative manner. So to confirm the correctness of the result, we have verified all the correlations we found by the statistical method. This figure shows the mechanism, how it works, the two-layer representation, and to discover the correlation. This figure is to try to find the correlation between the population density and the player volume. For the population density, it's showing on the background layer. So it's shown here on the left of the graph. So each county of California is filled using grading color based on the population density. So the light purple color means lower population density, and the dark purple is the high population density. The second layer is the front layer, is showing here at the middle graph, is showing the player volume. Player volume is represented as markers with a grading color. So we add these two layers together, that come to the graph on the right. Then we can clearly see the correlation between these two variables. That is, the higher is the population density, then the higher the player volume. This is another example from the correlation finder. And this figure is to try to find the correlation between median age and conversation volume. So for the background color is showing the median age, and the foreground markers showing the conversation volume. And we can see the negative correlation. So that is, the higher is the median age, then the lower conversation volume. Our tool really requires some intensive computation resource, especially for the first two steps, the data summarization and the geocoding, because our database is so big and a lot of data has to be processed. But fortunately, these two steps have to be done only once. And the result will be saved in the database and can be used for future study. Okay. So using the local computer and with 8 CPU and 12 gigabytes of RAM, the data summarization and geocoding took over 500 hours. So this looks like it's impossible. So that's why we have used Gordon to do this task. And we partition our database data into a couple hundred small pieces. Then for each piece, we run a job on Gordon. We use 8 parallel jobs with, for each job, we use 16 cores, and all jobs can be done within 48 hours. Golden team has been very, very supportive, has helped us solve many problems. So today we also like to appreciate the effort of the Golden team, and we like to say many thanks. That's all. Questions?
Dora, thank you very much. Let me unmute participants.
Presentation mode is now disabled.
Any questions from the group?
This is Sergio. I assume that all the players kind of have agreed by something they, when they sign up for the game, that they will be monitored and their locations and ages will be known and things like that?
Okay, that's a good question. The game log is collected by game company. They already pay attention on those issues, so they actually.
Okay, so if you want to play the game, then when I sign up with the company, there's something more or less fine print that says that they reserve the right to do this.
Yeah, and they must.
And that they can also then assign those rights to somebody like a researcher.
Yeah. What we really have is the account number, and we really don't know what's the player's name or what's the actually real street location. We only know it's account number and their zip code.
So is this
but also the age, I guess, somehow.
Yeah.
Oh, the age was from the census data, I think, Sergio.
From the census data. Oh, the census, like the U.S. census for that county or something like that?
Yeah, I think so.
Yeah, the game log contained the age.
Oh, okay, so it was from the game.
It's a participant age. It's not some, yeah.
Ah, okay.
But the census data also has age information.
When you say census, you mean the U.S. census?
Yes.
For that county?
Yeah, those census data is published online. It's some kind of average for each county or each.
Right. So it's a county average. That does not refer to the individual player.
No.
Okay.
Was this a one-time computation, or does this continue on, or?
Like I said, the process has 3 steps. The first 2 steps is only done once.
Okay.
What kind of challenges did you see integrating game logs in 3 different languages?
Yeah, it's a very challenging job, and because the language is very different, and I have done a lot of experiments, and I finally found we have to use Unicode for our database structure. So if we use Unicode, and this problem can be solved. But the only drawback is Unicode uses much more storage. Yeah, for the English ASCII letters and 8 bytes for 8 bits for 1 character, 1 letter. But for Unicode, you need 16, so it's double the size.
But I mean, various languages you only mostly you only need to take into account the alphabet, right? I mean, it's because it's, I guess, well-defined fields. It's not things like syntax and, I mean, there's not like natural language processing very much, is there?
Yeah, for the game log, actually, it's much simpler than the natural language processing.
Right, because
the foreign language only showing in the variables like the item name, like task name, and like stage name, or on the area name, those kind of things.
Right.
Of course, if you don't understand those that special language, and you still can do your analysis, because your analysis is really based on some other numeric values.
Yep.
like players' age and players' account number and those kind of things. So,
how did you pick the games?
That's a good question. And we try to pick up some popular games, but another issue you have to consider is we have to negotiate with a game company, and they have to willing to provide the game log to us.
Okay.
Dora, could you stop sharing your screen, and I'll go ahead and get JSIC set up while we field a few more questions.
Hope I know how to do it.
What would you say was the most computationally challenging piece? So you moved it to a beefier machine. Did you have to do any optimization in addition to the porting to Gordon to get things to go faster?
Oh, yeah. The computation challenge, there are several things very important. One is on the database side. We have a total probably 50 users, concurrent users online. So how to improve the database performance, allow the users to be able to access the data at the same time, and to ensure user can get a quick response for any queries. That's a big challenge. So I have done a lot of work to tune the database. And after we moved some applications to Gordon, and we also faced some challenges. For example, how to partition our data and to make sure we can take the advantage of Gordon. And that's really tricky sometimes. If you don't partition right and you don't get the right aggregations, and also you won't get a quick, efficient process. And also we have tried very hard on Gordon and try to find what's the best parallelism and how many nodes we should use, and for each node, how many cores we should use. And this is after some testing, some benchmarks, so we figured out